Picture the living room of an American home in 1939, not the whole room, just one piece of it, standing against the wall, or centered beneath the window, or positioned where the fireplace might have been in an older house, a radio cabinet, 4 feet tall maybe, walnut or mahogany, carved at the corners, cloth stretched across the speaker grill, an illuminated dial on the front, the names of distant cities and call letters printed on the glass, WGNKDKAWLW. This wasn't a small appliance you set on the shelf and forgot about, it was furniture. It weighed as much as a grown man. It took 2 people to move it, and it cost. In the late 1930s, a decent console ran anywhere from $110 to $250. That's when a brand new Chevrolet sedan cost $600. The radio wasn't an afterthought in the household budget. It was a major purchase, considered carefully, paid off over time, and it was worth it. Because by 1940, the radio was the center of American domestic life in a way that nothing before it had been and nothing after it quite matched. Nearly 9 in 10 American homes had at least one. That's more than had a car, more than had indoor plumbing, 90%. A piece of technology so thoroughly adopted so quickly that within 20 years of the first commercial broadcast, it had become as expected in an American home as a front door. The programs that came through those speakers were the common thread of a country. Amos and Andy was so popular that theaters scheduled around it. They didn't dare open until the broadcast was over. Jack Benny, The Lone Ranger, The Shadow, Burns and Allen. In 1933, Franklin Roosevelt sat down at a microphone and spoke to the country through its radios, not as a president at a podium, but as a voice in the living room, the fireside chats. Families gathered around the set to hear them, the same way a generation later they'd gather around the television. But first, they gathered around this. We tell the stories of what America built and how it fell apart. If that's your thing, subscribe. More of these are coming. Now let's get back to the story. The inside of that cabinet was a different world entirely. Open the back panel. The set was designed so the line cord detached cleanly, the back cover lifted away, and you'd see a chassis crowded with components, wires running point to point between connections, capacitors and resistors tucked between the larger parts, and rising up from the chassis, plugged into ceramic sockets, the tubes. They were glass, roughly the shape and size of a thumb, some a little larger, some smaller, depending on what they did, and when the radio was running, when you'd click the switch and waited the minute or two it took for the set to come alive, those tubes glowed. Orange warm through the ventilation slots on the back of the cabinet. A faint light in a dark room, the color of a candle. Each tube had a job. In the most common design of the era, as circuit engineers called the All-American Five, there were exactly 5 of them. One converted the incoming radio signal to a fixed intermediate frequency, easier to work with. One amplified that signal. One detected it and extracted the audio. One amplified the audio. One rectified the household current from AC to the DC the circuit needed to run. 5 tubes, 5 functions, each one a glass envelope containing a small heated filament, a cathode, a grid, a plate, and between them a vacuum. No air, just electrons, controlled. The filament was the thing. It was the beginning of the whole process. Apply current to the filament. It heats the cathode. The cathode emits electrons. Those electrons flow through the vacuum toward the plate, and the grid, positioned between them, controls how many get through. Vary the voltage on the grid ever so slightly, and you vary the current at the plate by a much larger amount. That's amplification. A whisper becomes a voice. It was an elegant system. It was also a fragile one. Those filaments burned, not quickly. A tube might last for years of regular use, but eventually, like any light bulb, they failed. And when one tube in a 5-tube series circuit went dark, the whole set went silent. That was the moment every family knew. The evening program, halfway through, a crackle, a fading, silence. You'd lean toward the set and look at the back panel, check whether the dial was still lit. Sometimes you could see it right away, one tube that wasn't glowing where the others were. Sometimes you couldn't tell just by looking. Either way, you knew what came next. The corner drugstore usually had a tube tester near the front. It was a big upright unit, console style, with a panel on the front covered in jacks and switches, and a meter with a needle that swung across a scale. Good, weak, bad. The replacement tubes were stored in a rack or a wooden drawer built into the base of the cabinet, organized by type number, each in its own small cardboard box. You'd bring your tubes in, pull them from the sockets at home, put them in a paper bag or a shoebox, note which position each one came from, walk them down. The process was simple enough that a child could do it. Plug each tube into its corresponding jack on the tester, set a few switches, push a button, watch the needle. Most of the time, one of them would read bad. You'd pay 75 cents or $1, take the new tube home, seat it back in its socket, replace the back panel, plug the set in, and the sound came back. That was the optimistic version, the case where the problem was a tube and you could reach it and the drugstore had the right replacement. It happened often enough that the tube tester at the pharmacy was a genuine institution. Radio shops had them, Appliance stores had them. Gas stations had them. Replacement tubes were a meaningful revenue line for any retailer willing to stock them. The tubes cost about $1 each to the shop. The markup was comfortable. But sometimes the problem wasn't a tube, or wasn't only a tube. Sometimes it was a capacitor that had gone out of tolerance, or a resistor that had drifted, or a transformer that had failed. Sometimes the set just needed alignment. The various circuits nudged back into the precise frequency relationships that had shifted over years of use. For those problems, you needed someone who actually knew what they were doing. You took the set to the radio shop. Not every town had one on every block, but in most American towns of any size, there was at least one, sometimes several, competing for the same customers. Some were affiliated with the major manufacturers. RCA operated a national service network. Zenith had authorized shops. More often, they were independent. A man, almost always a man, who'd trained for the work, hung a sign, and built a clientele. The shop might be a storefront on the commercial strip, or a room converted off the garage, or a space in the back of an appliance store. What it always had was a bench. The bench was the center of the operation. Long, covered in linoleum or bare wood, and almost never clear. Half disassembled sets lined up behind it, paper tags tied to their handles with the customer's name and complaint, coils of wire, a can of soldering flux, the soldering iron in its stand, the tip dark with use, capacitors in small envelopes, sorted into trays, tube testers, the portable kind for house calls, and beyond them, an oscilloscope, its green trace drawing signals on the face of the tube, and behind all of it, on shelves running the length of the wall, the manuals. They were thick. The RCA tube manuals alone, published regularly from the 1930s onward, updated as new tube types appeared, grew from 260 pages in 1947 to over 700 pages by 1975. The rider troubleshooter's manuals covered specific radio chassis, model by model, year by year. The NRI service manuals compiled schematics and alignment procedures for pre-war sets. Volume 1 alone was 4 inches thick and contained more than 1,000 individual diagrams. A working repairman needed all of it. The job, at bottom, was diagnosis. The customer described what the set was doing, or not doing. The repairman wrote it on the ticket, then he went looking. He'd start with the obvious. Check the tubes. Not just test them, but look at them. A tube that's shorted or drawing excessive current will sometimes be visibly different from its neighbors. Then he'd pull the chassis, set the cabinet aside, and take the circuit apart with his eyes. He knew what the voltages were supposed to be at each point in the circuit because the schematic told him. He'd take his vacuum tube voltmeter, a VTVM, a probe-tipped instrument that could measure voltage without loading the circuit, and work his way through. Converter stage, IF amplifier, detector, comparing what he found to what the schematic showed. If the voltages were off, something between the power supply and that point had failed. He'd track it down. A capacitor that had failed open, blocking current, or failed shorted, dragging the voltage down, or a resistor that had drifted far enough out of value to upset the operating point of the tube it served. He'd find it, replace it, put the chassis back, align the set if it needed it, check the dial calibration, put the cabinet back together. Then he'd plug it in and see what happened. The whole process might take an hour on the bench. For a difficult set or an unusual fault, it could take several. The shop rate in the late 1940s and into the 1950s ran roughly $2 to $3 per hour for bench time, plus parts. A tube replacement was small money, and alignment was more. A capacitor job, replacing the electrolytic capacitors in the power supply, which aged and failed in predictable ways, might run $8 to $12, parts included. For a console radio that had cost $150 new and represented real money to the family that bought it, that was a price worth paying. The repairman was not a celebrity. He didn't get a lot of credit for the things he fixed, but he had skills that were genuinely hard to acquire and genuinely useful. He could look at a schematic, a map of relationships and values, hundreds of components drawn in a two-dimensional web, and understand what it was doing. He could hear a distortion in a speaker and have a theory about which stage it was coming from. He could hold a failed capacitor in his hand and tell you how it had failed from the way it looked. That kind of knowledge took years to build. The neighborhood radio repair shop looked like a small business, and it was, but it was also the end of a supply chain that stretched from university physics departments to small-town storefronts, a system that had been assembled over 3 decades, and that, at its peak, employed tens of thousands of people across the country. To understand that system, you have to understand what a vacuum tube actually was. Lee DeForest figured it out in 1906. He called his invention the Audion. It was a glass bulb containing 3 elements, a heated filament, the cathode, which, when hot enough, boiled off a cloud of electrons, a plate positioned across the vacuum gap which collected those electrons when charged positively, and between them a grid, a wire mesh through which the electrons had to pass. Apply a small voltage to the grid, and you controlled a much larger flow of electrons between the cathode and the plate. You applied a small signal, you got back a larger one. That was the principle. Small changes in, large changes out. For radio, this was transformative. A radio wave arriving at an antenna is an extraordinarily faint thing. The signal from a distant station, by the time it reaches your receiver, might carry only a millionth of a watt. A vacuum tube, and then several vacuum tubes in sequence, could amplify that signal to something powerful enough to drive a speaker. Without the tube, radio as a mass medium was impossible. By the 1930s, the dominant circuit design for home receivers was the superheterodyne, a circuit Edwin Armstrong had worked out in 1918, and that had gradually become standard. The superheterodyne took the incoming radio signal and mixed it with a locally generated frequency to produce a fixed intermediate signal, easier to filter and amplify consistently, no matter which station you tuned to. This is why you could turn the dial, and every station came in at roughly the same volume. The 5 tubes in the All-American 5 were arranged to do this work, one as the frequency converter, one for the intermediate frequency amplifier, one as the detector and first audio stage, one as the audio power amplifier, one as the rectifier converting household AC to the DC the circuit needed. Each tube type had a specific number designation, the 12AX7, the 6V6, the 5Y3, the 12AU7. These weren't interchangeable. Each had particular electrical characteristics suited to its role. A repairman needed to know which tube went in which position in which set, what its operating voltages should be, how to test it, and what to replace it with if the exact type wasn't available. This is what the manuals were for. The tubes came from manufacturers who had spent decades refining the art of sealing glass around metal under high vacuum. RCA was the dominant name. Their tube manuals were the industry standard. Sylvania, based in Emporium, Pennsylvania, published a rival manual in a loose-leaf binder so pages could be swapped out as new types appeared. GE, Raytheon, Kenrad, Tungsol, Westinghouse all competed for the repairman's shelf space and the consumer's drugstore dollar. Each manufacturer had a dealer network. A Sylvania shop displayed Sylvania's promotional signs, stocked Sylvania tubes as a first choice. The neon signs advertising these brands became as familiar as any other commercial signage on the main street of a mid-century American town. The labor pipeline that supplied the shops ran largely through the mail. The National Radio Institute had been operating since 1914. James Ernest Smith, an electrical engineer and former trade school teacher, founded it in Washington, D.C., starting with 4 students in a room rented behind a movie theater. By 1923, he'd eliminated the classroom entirely and moved to correspondence only. Printed lessons mailed out, tests mailed back, a kit radio that students built as part of the course. It was, in the language of a later era, a distance learning institution, before distance learning was a concept anyone had named. In 1922, the NRI coined a word for its graduates, radiotrician. They registered it with the U.S. Patent Office in 1928. The word didn't entirely catch on. Most people just said repairman. But the intent behind it was real. This was a distinct trade with a body of knowledge and a set of skills, and the NRI was certifying people in it. By 1929, average annual enrollment was 18,000 students. The school had published more than 250 textbooks. It had a trade magazine. It had a technical advisory board that included at various times Leader Forrest himself, the man who had invented the vacuum tube that the NRI was training people to repair. Then the Second World War ended, and the enrollment numbers went somewhere else entirely. The GI Bill paid for trade education. Hundreds of thousands of veterans came home having spent years in signal corps units, in radar installations, in communications, men who had already handled radio equipment under pressure and who recognized what civilian demand for radio repair could mean for a career. They enrolled by the tens of thousands. By the mid-1950s, annual NRI enrollment was approaching 40,000 students. The Cleveland Institute of Electronics, founded in 1934, and the International Correspondence Schools competed for the same students. More than 1 million people had completed an NRI course by the time the school was sold to McGraw-Hill in 1968. That's the system. Tube manufacturers supplying parts, publishers supplying manuals and schematics, correspondence schools supplying trained labor, and at the end of the chain, in every city, in most towns, in a great many smaller communities, a shop, a bench, a man with a tube tester, and a soldering iron, and a wall of reference books, doing work that needed doing because the devices people depended on were too valuable to throw away and too complex to fix themselves. That was the key assumption on which the whole thing rested. It was about to become untrue. To understand what came next, you have to understand what the radio repair business was protecting. By the end of the Second World War, 95% of American homes had a radio. Not most homes, not affluent homes, almost all of them. The $30 tabletop bakelite set on the kitchen counter, the $60 floor-standing model in the parlor. In some houses, both, and a car radio in the garage. The radio was embedded in American daily life at a depth that's easy to underestimate now, partly because we've stopped thinking of radio as something you gathered around. But people gathered around it. The chairs in the living room faced it. The dinner hour worked around it. Children did homework with the dial tuned low. Families scheduled their evenings by what was on. The programs that came through these sets were not background noise. They were events. Amos and Andy, which had started in 1928 and was still drawing enormous audiences into the 1940s, was so central to the evening schedule that movie theaters coordinated their showings to avoid the broadcast. Jack Benny had his own time slot, his own listeners, his own running jokes that a whole country shared. The Shadow, Fibber McGee, and Molly, the Green Hornet. News arrived this way too. Edward R. Murrow broadcasting from London during the Blitz. September 1940, bombs audible in the background, his voice steady. "This is London." People stood in their kitchens and listened. They didn't turn it off and pick up a newspaper. The radio was faster. The radio was there. The console radio that cost $250 in 1937 was not just an appliance. It was one of the largest purchases a working family might make in a year. It sat in the main room of the house, and it lasted, if you took care of it, for decades. You didn't replace it when the next model came out. You maintained it. When it stopped working, you fixed it. That was not a cultural attitude that had to be argued for. It was the obvious response to an expensive object that had gone wrong. The repair shop existed because the radio mattered, and through the late 1930s and into the post-war years, the shop's customer base just kept growing. By 1962, 50 million of 53 million American households owned at least one radio. The sets were everywhere. They failed at predictable intervals. The repairman's business was as steady as any in town. Then, in the early 1950s, something new arrived in the living room, something that would initially look like good news for the repairman. The television. The television didn't kill the radio repair shop. Not at first. Not even close. In the late 1940s and through most of the 1950s, the television did something the repairman hadn't expected. It made him busier than he'd ever been. Here's why. An early television set, the kind a family might have bought in 1950 or 1952, a big wooden cabinet with a small round screen, contained as many as 30 vacuum tubes. 30. Where a tabletop radio had 5, a television had 30, and those tubes ran hard. Television circuits pushed their components at higher voltages and higher frequencies than radio circuits did. The tubes failed more often. The failure modes were more varied and harder to diagnose, and the sets cost a great deal. $279 for a Magnavox in 1948. Which adjusted for inflation comes out to more than $3,000 today. Nobody was throwing those away when something went wrong. The repairman, who had spent years working on radios, found that his skills transferred almost directly. Tubes were tubes. Schematics were schematics. The voltage measurements and the signal tracing were the same discipline applied to a more complex circuit. The NRI had seen it coming. They'd registered the word teletrician with the US Patent Office back in 1938, a decade before television actually arrived in American living rooms. By the early 1950s, they were offering full TV repair courses alongside the radio curriculum. The veterans who had trained on the GI Bill, opened their shops in the late 1940s, built their customer base in radio, now had a second revenue stream walking through the door. Service trucks became a common sight. Floyd Cox, an NRI alumnus, ran his operation out of a 1957 Volkswagen van, a mobile workbench, a stock of common tube types, the test equipment secured behind the front seats. He could handle most jobs in the customer's home. The television was heavier and more cumbersome than a tabletop radio, and a house call meant not having to haul it anywhere. For the customer, it was a convenience. For Cox, and the repairmen like him, it was just Tuesday. The trade reached its peak in the 1950s. Not the 1930s, not the 1940s, the 1950s, a decade when television was new and unreliable and expensive and everywhere at once, and when anyone who could diagnose a failed flyback transformer or a shorted damper diode could count on more work than he could comfortably handle. This is the part of the story that tends to get lost. The radio repair shop didn't go into decline when television arrived. It evolved, absorbed the new technology, and thrived. The repairman of 1955 was, if anything, more secure in his livelihood than the repairman of 1935. What happened next came from a different direction entirely. On December 23, 1947, in a laboratory at Bell Telephone's research facility in Murray Hill, New Jersey, 3 physicists made a demonstration to a small group of colleagues and managers. William Shockley had been guiding the project. John Bardeen and Walter Brattain had done the bench work. What they showed that afternoon was a device smaller than a thumbnail, two fine wire contacts pressed against the surface of a small block of germanium that could amplify an electrical signal without a vacuum, without a heated filament, without a glass envelope of any kind. They called it a transistor. Bell Labs held a press conference 6 months later, on June 30th, 1948, at which they presented the transistor to the world. The coverage was respectful. A few publications noted that it might one day replace the vacuum tube. The general public mostly moved on. The radio on the kitchen counter still worked. There was no reason yet to think anything was about to change. For the next several years, the transistor remained largely a military and industrial component. The reasons were straightforwardly economic. In 1954, a single transistor cost $20. A vacuum tube cost about $1. For a consumer device that needed 5 or 10 active components, the math didn't work. The major radio manufacturers, RCA, Philco, Emerson, looked at the numbers and passed. Vacuum tubes, they concluded, were still the right answer. Texas Instruments disagreed. They were a young company based in Dallas, and they had been working to bring transistor production costs down. By early 1954, they believed they had gotten them low enough for a consumer product. They approached the major radio manufacturers one by one with a proposal. TI would supply the transistors. The manufacturer would design, build, and market the radio. RCA said no. Philco said no. Emerson said no. A small Indianapolis firm called IDEA, Industrial Development Engineering Associates, said yes. The Regency TR1 went on sale on October 25, 1954. It was smaller than a paperback book. It weighed 12 ounces. It came in 4 colors: black, red, gray, and ivory. It used 4 germanium transistors, hand-picked in match sets for consistent performance, and ran on a single 22.5-volt battery that lasted 20 to 30 hours. No warm-up time, no glow. You switched it on, and it was simply on. It sold for $49.95. That's more than $500 in today's money, which meant it was not cheap, but it sold out by Christmas. Not because it sounded better than a tube radio. Reviewers were honest that it didn't. The audio quality was thin compared to even a modest tabletop set. But because of what it was, you could put it in your coat pocket. You could take it to the beach, to the park, to a picnic. It was radio that went where you went rather than radio that waited for you to come home. Within a year, a young Japanese company called Sony, previously Tokyo Tsushin Kogyo, had released its own transistor radio. Then another. Sony's TR-63, released in 1957, became the first transistor radio to sell in the millions. By the mid-1960s, the TR-63 alone had sold 7 million units worldwide. Japanese competitors followed Sony into the market: Toshiba, Sharp, Hitachi. By 1959, Japanese manufacturers were producing more than 6 million transistor radio sets for the American market alone, representing $62 million in annual revenue, and the prices kept falling. A transistor radio that cost $50 in 1954 cost $15 by the early 1960s. The same basic device, pocket-sized, battery-powered, no tubes, no warm-up, no fragile glass to protect. $15, less than many families spent on a week of groceries. Here is where the economics of the repair shop began to shift in ways that couldn't be argued with. The entire business model of the radio repair industry rested on a single assumption: that the device was worth more than the repair. A family that had paid $150 for a console radio in 1938 was not going to throw it away because a tube had failed. Of course they weren't. They were going to carry it to the shop, pay the $8 or $12 to have it put right, and carry it home. The investment justified the maintenance. But a family that had paid $15 for a transistor radio in 1963 was doing a different calculation entirely. The bench charge at most shops was running $3 to $4 an hour by the early 1960s, plus parts. A diagnostic visit alone could cost more than the radio was worth, and the transistor didn't fail the way a tube failed: predictably, individually, replaceably. The transistor was durable. It didn't burn out. The parts that did fail on a transistor radio tended to be the capacitors and the speakers, components that were cheap at the factory and relatively expensive to replace individually in a shop. The family looked at the broken transistor radio. They looked at the shop rate. They walked past the shop and into the hardware store and bought a new one. Not every time, not all at once, but often enough, and increasingly often through the late 1950s and into the 1960s, that the radio side of the repair shop's business began to quietly hollow out. The repairman still had television, for now. The transition didn't arrive as a single moment. It arrived as a direction, a gradual, persistent tilt in the economics that only became obvious in retrospect. Through the late 1950s, the shop was still busy. TV repair was strong. The sets were expensive and unreliable enough to justify the service call, and the repairman's skills were still the right skills for the job. The tube tester still had a function. The schematic library still got opened. The bench rate still covered the overhead, but the composition of the work was changing. Walk into a radio repair shop in 1962, and it was already more of a TV repair shop. The radio benches quieter, the television sets lined up waiting their turn. The shop owner might not have worried. Television was the bigger revenue anyway. What nobody saw clearly from inside the shop was that the same forces eliminating radio repair were working their way toward television at a pace set by manufacturing and materials costs rather than by consumer preference. Each year, the television sets got a little more reliable. Each year, the price of a replacement set came down a little. Each year, the calculation that justified a repair rather than a replacement shifted a little further toward replacement. The integrated circuit arrived in 1958. Jack Kilby at Texas Instruments, working on a problem that had been obvious since transistors appeared. The transistor solved the tube's fragility problem, but a complex circuit still required hundreds of individual components, each one soldered in by hand, each connection a potential point of failure. Kilby's solution was to put everything, transistors, resistors, capacitors, their connections, on a single chip of semiconductor material. What had required a chassis full of discrete components could now be done in a piece of silicon smaller than a fingernail. By the mid-1960s, integrated circuits were appearing in consumer electronics. The circuits became denser, the boards became smaller, the components became harder to see and harder to reach. A PCB in a calculator of that era held about 30 transistors. A decade later, a single chip held thousands. The progression was relentless. Motorola had introduced printed circuit boards into home radios back in 1952 after 6 years of development and $1 million research investment. Point-to-point wiring, the hand-soldered connections that a repairman could trace with a finger, was giving way to etched copper traces on phenolic boards. The repairman could still work on these boards. The traces were large enough to see, the components were still through-hole mounted, their leads poking through the board and soldered on the underside. With patience and the right tools, faults could be found and fixed, but it required different tools. An oscilloscope became more essential, not less. The VTVM gave way to digital meters. The work became less about tube testing and more about signal tracing through transistor stages, measuring gain, checking bias points. Some repairmen made the transition. They retrained, bought new equipment, adapted their schematic libraries to the new manufacturers. Others looked at the investment required and did the arithmetic. By the 1970s, the verdict was becoming clear. Solid-state electronics were more reliable than vacuum tube electronics had ever been. A television built in 1972 was far less likely to need service in its first 5 years than a television built in 1957. When it did need service, the fault was often on a circuit board that could be swapped as a unit, pulled out, sent to a depot for repair or replacement, the set back in the customer's living room the same day. The repairman became less a diagnostician and more an installer of replacement modules, and the prices kept falling. A color television that cost $800 in 1968, a substantial sum still worth repairing, cost $400 by the late 1970s. Portable black and white sets could be had for $50. The same tipping point that had killed radio repair was moving toward television repair, pushed along by the same forces: mass production, Japanese manufacturing efficiency, and a consumer electronics industry that had reorganized itself around replacement rather than maintenance. By the 1970s, the repairmen who were still working described a business in slow contraction, not a collapse. There was still work, but the phone rang less. The bench had fewer sets waiting. The radio corner of the shop had been dark for years. The NRI was still training students, but the courses had moved on. Solid-state circuits, television, eventually computers. The word radiotrician had long since stopped meaning anything to new students. It belonged to a previous era. What happened to the people who had built their working lives around the trade? Most simply aged out of it. The men who had trained on the GI Bill in the late 1940s were in their 50s and 60s by the 1970s. They retired when the work thinned, passed the shop to a son if there was one interested, or simply closed the door and handed the lease back. There wasn't a next generation waiting to take over, because the economics that had made the trade viable for 30 years were no longer there. The tools went various places. Some were sold at auction when the shops closed, tube testers and oscilloscopes and VTVMs that ended up in garages, at flea markets, eventually on eBay. The Hickok tube testers, the ICO units, the Seco cabinets. They became objects of curiosity, then objects of nostalgia, then collector's items commanding real money from the people who remembered what they were for. The NRI course manuals, which a working repairman had used until the covers wore soft, became archival documents. Entire course sets have been scanned and distributed on CD. The rider troubleshooter's manuals are archived online. The shop buildings became other things: a pharmacy, a pizza place, a real estate office, the one in Minneapolis that appears in period photographs, a Sylvania shop, neon sign in the window, is, by the accounts of people who knew it, now a scuba shop. The National Radio Institute itself lasted until 2002, 88 years. It adapted through every technological shift, tubes to transistors to integrated circuits to computers, training students by correspondence through all of it. When it finally closed its doors on March 31st, 2002, the building on Wisconsin Avenue in Washington, D.C. was purchased by Fannie Mae, the school that James Ernest Smith had started in a room behind a movie theater, that had coined the word radiotrician, that had administered 1.5 million correspondence courses across nearly a century, was done. The work it had trained people to do had, in the main, stopped existing. There's a tendency when you're talking about something that disappeared to conclude that its disappearance was a kind of failure, that somebody made a wrong decision, or that something good was carelessly thrown away. That's not quite what happened here. The vacuum tube radio repair industry didn't fail. It succeeded, completely, for the better part of 40 years, and then it was replaced by a different way of doing things that was genuinely better in several important respects. Cheaper electronics meant more people had access to them. More reliable electronics meant fewer disruptions to the daily life those devices had become part of. The transistor radio that a teenager could buy for $15 and carry to the beach in 1963 was, for that teenager, a different and fuller kind of freedom than the console radio in the living room had ever represented. Radio went everywhere. It got smaller and lighter and cheaper, and it became part of a portable, personal relationship with sound and news and music that the furniture radio of the 1930s could never have offered. The integrated circuit and the printed circuit board made it possible to put extraordinary complexity into very small and very inexpensive packages. The devices that followed, the pocket calculator, the personal computer, the mobile phone, all descend directly from the same technological progression that made the radio repair shop obsolete. It's the same river. So, the gain was real. It should be acknowledged plainly. But something was lost too, and it wasn't only the shops. What was lost was a particular relationship between people and their technology. The tube radio was designed to be understood. The back panel came off. The tubes were accessible and labeled by type. The schematics were published by the manufacturers and compiled by independent publishers and made available through trade schools and correspondence courses and the druggist's trade counter. The assumption built into the design of those sets and into the industry that grew up around them was that when something went wrong, it should be possible for a trained person in your community to find out what had failed and put it right. That assumption has not survived into the present. The devices we carry now are sealed, their components are microscopic, their circuit boards are multi-layer assemblies that cannot be meaningfully repaired at the component level outside a factory setting. When something fails, the expected response is replacement of the module or of the device. The knowledge required to diagnose and repair them is not distributed through correspondence schools and neighborhood shops. It is held by the manufacturers, expressed in proprietary software, and largely unavailable to the person who owns the thing. This isn't a complaint. It's just an observation about what the change in technology brought with it beyond cheaper prices and greater convenience. It brought a different relationship. The person who owned a 1938 Zenith console radio was, in some modest but real sense, in a relationship with an object that could be known and maintained. The person who owns a 2024 smartphone is in a relationship with an object that is intended to be leased and replaced on a cycle determined by the manufacturer. The tube tester at the drugstore is maybe the best way to hold this in your mind. A machine available to anyone, no appointment necessary, no expertise required beyond knowing which tube came from which socket. You brought your problem with you? You found your answer at the counter. You paid for the part you needed and went home and fixed the thing yourself. The entire repair infrastructure, the schools, the shops, the manufacturers, the publishers, all of it existed in support of that simple transaction. It was a different kind of relationship with the objects in your life, not better or worse in any absolute sense, just different, and it's mostly gone now. What remains is small but not nothing. The Antique Radio Club of America still holds annual conferences. The California Historical Radio Society maintains a repair directory for people restoring vintage sets. The Museum of Radio and Technology in Huntington, West Virginia, has reconstructed a period radio shop, bench, tube tester, schematic library, the whole thing, so visitors can see what it looked like. The tubes themselves never entirely went away. Electric guitar amplifiers, the Fenders and Marshalls and Voxes that defined the sound of popular music in the 1960s, were built around vacuum tubes, and the musicians who played through them preferred what they did. Roughly 80% of the high-end guitar amplifier market, as of the 1990s, still insisted on all-tube or hybrid designs. The 6L6 beam tetrode that RCA introduced in 1936 is still being manufactured in Russia and China now, not Pennsylvania or New Jersey, but the tube is still being made, still being bought, still being seated into sockets by musicians who believe, with good reason, that it sounds better than what replaced it. Some audiophiles agree. The 300B triode, first made by Western Electric in 1935, is still in production. There are people building vacuum tube amplifiers in their workshops right now, winding their own output transformers, sourcing new old stock tubes from the estates of deceased collectors, chasing a particular quality of sound that solid-state electronics has never quite reproduced to everyone's satisfaction. These are small communities, devoted, knowledgeable, genuinely skilled, but small. The trade that once employed tens of thousands of people in shops across the country now lives in the hands of a few thousand hobbyists and enthusiasts who would almost certainly have been very comfortable at the bench of any radio shop you might have walked into in 1948. The knowledge didn't entirely disappear, it just moved. In most American towns, for most of the 20th century's middle decades, there was a man within a short drive who could take a broken thing and make it work again. Not a corporation, not a service plan, not a chat window. A person, with a bench, with a wall of reference books, with the skills to look at your problem and understand it. He charged $2 or $3 an hour for his time. He kept a stock of parts. He answered the phone when you called, and he wrote your name on a tag and tied it to the handle of your set. And he called you when it was ready. And it usually was ready. The set that had gone silent came back with sound in it. That was the radio repair shop. Not glamorous, not celebrated, not the kind of thing that makes history books or museum retrospectives with very few exceptions. Just useful, steadily, for a long time, in a way that a great many people quietly depended on. The transistor came, and then the integrated circuit, and then the sealed plastic chassis, and the economics changed in ways nobody in the shop could have reversed even if they had seen them clearly. The tide went out the way tides do, gradually, then all at once, then simply gone. If there was a radio or TV repair shop in your town, if you remember the name above the door, or the smell when you walked in, or what it looked like to watch someone work a tube tester, we'd genuinely like to hear about it. Drop it in the comments. Some of the best history in this series has come from people who are actually in the room.